So in the wind turbine blade optimization homework, you have to go into your wind turbine model and suppress the variable thickness. The optimization doesn't work with the variable thickness, so that's a limitation. So you can right click and say suppress. You see it's suppressed over here. So you suppress these two variable thicknesses, and then when you go to each of these so-called surface bodies, you can see that this thickness that's entered becomes the thickness of that surface, which is an important parameter in shell models. So I have selected the units to be millimeters. And to see which surface corresponds to what, you can go to the wireframe view, and let's say I highlight this surface. In fact, let me highlight this surface and then go back to that. So, and if I zoom in here, you see that this one is the first part of the spar. This one is the second part of the spar. That one is the third part of the spar, and all of these you set to 50 millimeters. And then that is the fourth part of the spar. So let me zoom in and manipulate the view here. So you can see that by this green highlight. And then the fifth one is actually, I believe it's the front surface, and I can see that better if I go to, if I switch to shaded exterior and edges. And so the surface highlighted in green, okay, so this surface is the front surface. In fact, you can, maybe it's a good idea to rename these. I haven't done that, and that way you're not confused. So that's the front surface because the wind is coming along -z, and then you have another surface. The next entity is the surface at the back, which is highlighted in green. And then this is actually another part of the spar. So the spar is split into multiple surface bodies, the way the CAD was done. So again, if I go back to the wireframe view and zoom in here, I see that, okay, that's also part of the spar. And then that you see is the root surface, and that you set to 100 millimeters. So if I go to view, shaded exterior, I see that root surface where you're going to have the biggest bending moment has a higher thickness. And then the last one is the tip surface. So if I zoom in here, I see I can go to rotate about this pivot, and then I can see it better. Okay, so that way you can review which surface is which, and then you can set the starting thicknesses appropriately, and then these two surfaces, you can see this one is a parameter that you want to optimize. So you want to figure out what should be the thickness of this surface and of that surface. One is the front and the other is the back.